Good morning. So I also want us to model this our structure in Staad.Pro. No, we modeled here and imported it in Staad.Pro. So let's see if we can be able to model this same truss in Staad.Pro before we proceed. I wanted to proceed from that one, but I said no, let's do something that will now see how we can do it in Staad.Pro too. So I will discuss earlier and did our introduction. This is a setup. We work from here to down. So this is the setup where you put the job, then the client's name, the job number, revision. You have revision. So you fill up this, the engineer, the checker, those people. That is where you do all that. So now you move to geometry. So when you come to geometry now, I don't model using these grids. I cancel, or you just cancel once. When you now cancel once, you now enter your first grids. 0. You enter your first grid 0 0. Good. So this is your first grid. So when you enter your first grid now, you now select, you pick your node cursor, you select this node, you can right click, you copy it, and then, but before that let's make sure that we're in the front, so that as we're moving like this, as we're moving in the right direction, we're moving in the X direction. So you make sure that in our front. So now right click this, and then we paste nodes. So paste nodes in the X direction. Since we're working with meters, right 30. Good. This is the 30 meter span. Yeah, that is from here to here is 30 meter span. So it all depends on where we want to move from here. Okay, we can see create another node. We can see paste node at X direction 15 meters. Is the middle here. Good. So you can select this node, copy it, and then paste node in the Y direction. This is our Y direction. Let's check it. Our Y direction has this good. You first model it here so that you can have all those distances depending on your angle and slope. Yeah. Then this distance here will move up to 4,600. And it's 4.6. Yeah. Then this node again, you copy, paste, save as, just save. You paste that node in the Y direction. What distance? Let's measure from here to here. Distance of 1 meter. Y1. Good. We have done that now. So what should be the next thing that we'll do? Let's check. Let's come this side. We need these vertical distances from here to here, here to here. But let me just drag something very tall like this. Something like this. Copy selection. I can remove the auto, then drop it at these places. anyhow you can do and identify, make for easy work. It's left for you. Okay. So we can, since these things are equal, let's see, we have a truss spacing of 1 2, another spacing of 1 250 in the horizontal direction. So what we can do here is, let's see, we can copy this one here, copy it, paste node in the x direction 1.250 meter. Good. That's it. This is from here to here. Alright. So from here to here is what? We have 383. Three 0.383. Good. From here to here, and then let's measure from here to here. We have 545. Copy. 0.545. Okay. Yep. Let's see. I'm done with this one. We still move another way. But if you like now, you can connect this. You can pick your add beam and you connect here and here. You can also connect there and there. Yeah, sure. Align. Let's check our align. So let's check out what is here. 504. So copy and paste in the y direction 0.504. You leave it that way. Okay. Alright. Yeah. So what we'll do now is let's delete these nodes first. Good. After deleting these nodes, now let's add a beam. Add beams. Let's pick a beam here. and come here, pick another beam here and come here. Alright, so now we'll now insert nodes on this beam, but before we do that, we'll come to our AutoCAD and check how many nodes do we have. Starting from here, let's say this node, let's say this is 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 11. Yeah, we'll now insert 11 nodes. Okay, so pick beam now, select beams, then we'll right click and we'll check insert nodes. So when we come to insert nodes now, we'll come here and then let's add 11. Good. We have successfully achieved this. Yes, so let's see how we can also do it this side too. So this is where our 30 meter is ending. This is the place our 30 meter is ending. So that is there. We'll measure here. I think it's 0.504. Good, that's it. So now offset. We'll pick node cursor first. We'll copy it and then with V, then the Y direction of 0.504. We'll press OK. Now we'll pick our nodes, add beams nodes. That is add beams. We add it there. Alright. So pick nodes now. This one is useless. We just wanted to use it to get this. This one too wasn't necessary. Yeah. So now pick beam cursor. Select the two. When you select one, you press your control. Select the next one. Insert your nodes. We've already done the math in AutoCAD. I know how many. Then press OK. Okay. We see come to our AutoCAD here, and we check more. This is our if. We check the depth of our if 600. Alright. Now what's this? 300. Okay. So now copy this. Pick our node cursor. Copy this. Ctrl C, Ctrl V. In the X direction, we go 0.6. We copy this. Ctrl C, Ctrl V. In the Y direction, we go 0.3. Good. Sure. That's good. We'll do same this side. We'll copy this. Copy V. In the X direction, we'll go minus 0.6. Good. Then we pick this. Ctrl C, Ctrl V. We cancel. I pick 2. Yeah. Ctrl C, Ctrl C, Ctrl V. We'll move it at 0.3. Good. So now pick our beam. Pick our beam here. connect this to this, connect this to this, we connect this to this. Alright, we'll come this side, connect this to this, to this to this. That's nice. Then we'll now insert our verticals. Then now supposed to have a web member there. That was good. Good. So, ladies and gentlemen, we are done with our modeling. We have modeled it in 18 minutes. It didn't take much time. At least we have done. We've tried. At least this the section. Yeah. So the next thing now, we'll create our support. Then move to we have finished geometry. We'll move to model. Then support. Okay. We click on create. Alright, fix. We're fixed using. We're going to use pin support. Yes. We add, assign. You, as we did that time, use cursor to assign. We assign the support here. We assign another one here. Assign. Yes, we have done that. So what I do next is I assign properties to them. Okay, so we click on properties. We click on properties now. Now click on your edit. Hello? Okay. Sorry, you click general. Let's say you go to your geometry. So when you now come to general, you see section database. This is where you click. Yeah, you click on your section database. So like I said, you finish modeling. Immediately you come under section database, you don't press anything in the subsection there, you just come to sec. When you finish your geometry, you come to general, then you click on your section database. So you come here now, then you go to the code you want to use. Let's say you want to use British, then we want to use angles. I will choose 2 angles. Let's say we're using universal angles of 100, 75 and 10. Let's add it, and then we're also using 75. Let's use equal angles, please. $100 by 100 by 10. And then we use 75 by 75 by 8. Yes. Then for so we also choose for channels, that is for the pole lines. Yeah, we choose channel. Let's say we use a channel, we'll try a channel of 150. If it's higher, you can design back. Or let's say a channel of 150. Or let's use a channel of 100. Yeah, then we'll add, then we'll close. Let's delete this one. Wasn't my intention, it was mistakenly added. So now for the top and bottom chords, I will select my tops, I'll select my both top and bottom chords. If you are not selecting where, you can enlarge it. Or I'll enlarge. So, I made a mistake. The big one. Really a big one. I didn't select here first. I was supposed to select the universal angle first. Good. Now I can use this zoom, so I can bring out the portion good. I'll start selecting. Can make it bigger. The top and bottom chords. And now assign. Good. I can't see zoom again until I cancel that one and then come to zoom, enlarge it, select. Top and bottom chords. Then now we'll go for this one, for this struct. cancel that up, pick this one, pick this. Okay, so I'm done assigning my properties. So I'll select the whole of this, and then use translational repeat. I want us to put our polylines, design our polylines in the software today. So the default step spacing, this one has to do with the number of spacing along. Let's say the architect has suggested that the column should be spaced along the length of the building, like 4.5 meters. So write our 4.5 meters. Then the number of steps, let's say 5. We won't do much. Then it's going in the Z direction along the length of the building. Then we'll now press OK. Let's put it in 3D and see what we have here. Alright, that's what we have here. So put this in the, so we want to connect our polylines now. So along the length. So pick node cursor. I'll start selecting. Select these top nodes. So let's keep selecting. So when we're done selecting, we now come to geometry, then say connect. We look for connect beams along the Z axis, telling us no member is created. Geometry. Or another way I'll go about it is, now I'm in 3D, so I'll still use translational repeat. It's going the Z direction. Then it says we'll still use our spacing of 4.5. We say that we want to be 5 numbers, as same as we did that time, but this time we'll link steps. Now we'll link it. Good. We have successfully connected it. Alright. So now let us assign properties to our polylines. So there are 2 ways of selecting these polylines. We can, they're the only one that we haven't assigned anything to them, so we can just say assign by missing attributes. We say property, we have selected it. Or what's another way we are going to use? Another way that we can see select it is by, we say select parallel to, Let's check parallel to. Parallel to. Select being parallel to Z. Good. It has done the same thing. We can now assign our CH sections. Good. We have done that right now. So now that we've successfully modeled, let's do our loadings. We'll come to loading, load case detail. Then we add, let's call this dead load. Dead, we add life load, roof life, we add wind load, we close. So by default now, the safe weight of the section we come in is here, going in the -y direction. And we add, okay, close. Let's see. So let us now add another dead load to on our poline. So we come to member load and under uniform member force. That is if you are putting poline. Yeah. So now from our old load analysis, the first design we were not putting polines, we were not doing truss spacing, so we multiplied our load by the distance so that we now fixes on those nodes. But in this design we have also included we have modeled our polines, so we are now doing truss spacing. So we are not including this one. We're not including this distance. The software will take care of the distance. So what we'll do here is we'll only multiply for dead load. Now we'll multiply our 0.65 times 1.553. Okay, our load now, let's say our load is 1.1. That is our load on poline. So let's open our poline. Let's open our load here. Yes, minus 1.01. We'll add, we'll close. Yes, and also come to our life load. So for our life load too, we now assume, we will not assume a value. Let's calculate from our old work 0.5 times 1.5. So let's multiply that and see. 0.5 times 1.5, 0.75. Okay, so now we'll put here minus 75. We'll add, then we'll now close. Yes. For wind load now, I need to define it. I'll go to now definition, open definition, wind definition. I'll add, yes, add, I'll close. So now we press here, we come to add. Then this is a code that we use, AS code. Immediately you click on it, you come to this place. We use the version 2010 as the latest. So then we assumed wind speed, the one usually used in Nigeria is 40 meter per second. Yeah, you change the unit to meter per second. So after doing this, you click on apply, you say okay, yes, you add this, then the factor 1 you add, and then you close. So for us to make sure that our polines are not transferring moments, we will now release, we will do full release moments in our polines. So we'll now come to specification. That is under general specification. Then we'll click on beam. Then we'll come to release. From the start of the beam, full release, both X, Y, and Z. You now add, see, come again at the end, M, X, M, Y, M, Z. We add, okay, alright. So for us to select this, so we want to select this. There are many ways. When we come to select, we can select by, we can come to select by all. No, not all. Yeah, select beams. We can say select beam parallel to Z axis. We can do that. Then there should also be another way we can select. Select by specification. Let's see, property name. We can select channels. It has also it has also been selected. So since I select this one, I will assign can't assign. Let me see. Then cancel it. Okay. Alright, it has agreed. When I cancel that, it has assigned. Then the up one too, I'll go and then assign. So we have successfully done that. So we'll now close this. We'll go back to our loads. Win loads definition is there. Okay, yes, sure. And then we'll now select that exposure. This is the exposure, and we assign to view. There's the whole project. Okay, that has been done. Then we'll now click this win load and add. Then we'll come to win load. Then we have this environment here. Okay, so I'll leave the minimum at 0. Then the maximum has to do with the height of your roof truss. So let's say 5 meters, or let's say 5.5 meters, or let's just say 6 meters. Then we'll add, then we'll close. Yeah, okay. So now that I've clicked on this, I can see how the wind is acting to the building. Yeah, so we'll now proceed to apply. We have to apply our self weight. Let's select the whole building, select view. Our self weight have been applied. So now we want to apply our dead load, but this dead load now we only apply on the pole lines. Is the pole line now transfer it to our trusses? Yes. So what we'll do now, we'll come to select, let's say by all, no, not by all. Let's say we are selecting by specification, then property name, then we choose this, our polyline. Then we now, since we choose that, telling us to close, choose that, assign, we assign it to selected beams. Yes, that has been done. Good. That has been done. We'll now move to our live load. Yes. I also assign it to selected beams. Good. That also has been done. So the next thing is for us to do our combination load. So click on load case detail. We'll click on add auto combination. Let's choose the code British. Then we can generate it. Yes, I've done the generation. We'll click on add. Then we'll close it now. Okay. Right, so you can see the load combination here, 1.4 multiplied by the first load and 1.6 as multiplied by their load and 1.6 multiplied by live load, 1.4, 1.4, 1.4. So is when we analyze now, we now choose the one with the highest, the load combination that's give us the highest load. That's the one that we're definitely going to make use of. This 1.222 have to deal with our wind load and the rest. Okay. Alright. So after adding doing all the loads, come to analysis and design, print all, we add. We now close. So the next thing we'll do right now is we'll click on design, then we'll define our parameters. So we'll now check our PY, which is design strength. We add, we can close, we'll come back here and assign it to view. Good. We've assigned our design strength to the view. Okay. That's done. Then the next thing is we click on this command. But before then, you make sure that your code is this one, BS 5950. When you press on command, then check code. We're telling it to check the code for you. Add those to add them later. Then you can, if you want it to group it for you, then you want it to select members for you, you will add. Yes, then you also want take off. Yes, that's how it is. So let's close for now. Then we'll come here, code check to the view. We check the code. Okay, this is also help us to select. Good. That is all for now. Let's see. So I can close this and then let's analyze. Okay. Okay, have 0 errors, 2 warning. Okay. I have so many nodes. So are nodes due to our this thing. So we'll scroll down to where we have our sections. Okay. Alright. This pass. So these are the one that we choose. Yes. Unless otherwise noted. The first one has a this is the code that these are the members that we choose ourselves. You can see that most of them are passing. Most of them are passing. So that it passed, most of them passed. So maybe if we're doing this session like this, you can even reduce the load and see what you can get, what you can get. Yeah, you see pass this fail. Okay, there's been 119. You can take note of it. 122 fail, 123 fail. So our critical beams. I can just use my phone and snap so that when I go to where I can trace it, I should be able to know which beam they are talking about. This one's free. Something. Then this one we call the Staad.Pro member selection. So I think this is the one that Staad.Pro. The one that Staad.Pro selected. So from beams I'm concerned with, the beam 123 that fade. Like when you see here, non-fade, these are the ones they reselected. Beam 123, they now choose 120 by 120 size. Okay, that's good. Okay. We go down. That means our top and bottom cores will be 120 by 120, but we'll know the location. We'll get there. Let's go down. These are the ones they selected for us. Okay, so these are the channels that you choose. 125. So the 100 didn't work, but 125 worked. Yeah, in our manual design I checked for 120, 150, and it works, which shows that the manual design that I did for the channels, yes, that's for the poline. The manual design I did for the poline showed that I checked for channel 150, it worked. So in this case 125 is working. Yes, since it's almost carrying the same load at each pan, the whole of it is 125 instead of the 100 I would choose. 125 by 65 by 15. Okay, so that is about this results here for now. So if you want to print anything here, it's easy. Let's see on print preview, you go to the page that you want to show. Let's say these are the pages that you want to show. Any of the page, see, move the next page. As you can see, depends on what you want to print. All the results are there. You print, you convert to PDF, whatever way you want. So that's part of it there. So we can now move to post processing. Good. We're now here in post processing. So now let's locate our beam of 123 and 122. Those beams are fade. So these are beams. This is on that beam. So far, one. This is beam 121 past, it's 122 that fade. Okay, let's see here. Good. Those beams in these directions, so these are the ones that are failing. This very beam fade at 100. See, when I selected it here, it also selected this side. So you can see these are the load, the dead load, the live load, and then you can see the generated load. Point 2.32. There's only the wind. The wind load. No. These are not loads. These are the distance. We'll go to the side for loads. Okay, so now this is our reactions. So our reaction, this is the X direction and the Y direction. Okay. Alright. Good. Our Y is up. So our Y is definitely that our vertical load is going to be up. Let me take shot there. Yeah, till this is our reactions. So when you click that there is displacement, stuff like that. So changing this our load combinations, you are seeing this one has the highest load combination. Y is around 92. That load small, that load small, wind load small. Yeah. The fourth one, this is the life and death combination, have the highest load there. Okay. So let's now check that the other beams. When you come other beams, this is where you come in contact with the load. So we're checking beam 23, beam number. Beam number. Beam number 1, 2, 3. 1, 2, 3. There's 1, 2, 4. Good. I've passed it. Yeah, I just wanted to be sure. Yes, this beam here. Those are one of the beams that are very high. Okay. So let's see the first generated loads. Yeah, you can see those loads here. The FX, the FY, and the rest. Yeah. So these are one of the beams that were designed at 120. So you can see that is critical. That one of our critical beams. Yeah. So you just okay. One of our critical beams. Okay, good. So let's still do something. Let's come back to our modeling. Let's go back to modeling and do something. Design command. Let's try to group. Group this and see. Are we grouping? Let's see. View. Okay. See, analyze. Okay.
You don't quarrel.
Winds are high now. Okay. Oh yeah, we could have the results. Let's see this load. Let's go to beam. Let's go to beam. 500. That one is around 500. Generated load. Okay. It's around 600. Okay. You can go through this load and see which one has it. IS, let's zoom. Good. Okay, even here you can see properties. Property. The geometry. The choose. This is the beam number. Choose. This is what it choose. Yeah, you just take your time. You double click. This one choose. This one is even higher. Let's see. Okay, 75. Mm-hmm. 75. What are these? 75. Okay, this was the one we choose. Then the design 100. Yes. This is the one we choose, 75. The design 100. So that means our structs. So that means when we're detailing our design in AutoCAD. When we're detailing our design in AutoCAD now, our structs here will be 100. We'll specify our truss. Yeah, those are our vertical and diagonal chords to be 100 by 100 by 12. Why? Let's keep checking, but we hope that something is not more than that. This is the designed one. Good. Okay, all right. So the vertical and horizontal chords, while our diagonals, we will just need to choose the highest and work with it. put this in. So which are the beam? Let's see. Beam 1. The beam here of 123. Okay, I think it's the bottom curve that even 123. One of them will be okay. Okay. Let's see. Okay. Okay, this one's at the bending. Alright. So the deflection. Design property. Okay. Okay. This member selection 123. Okay. This just you go through it. Try to select, check a member, check the highest members that will be used for your detailing. Okay, so let's opening a design. This is how your detailing is going to look like from this. You develop this. These ones are the red. See that red line? Good, this is it. That red line. This red line here. This is what is here. You just need to draw these ones based on your $75. You just need to draw this based on your dimension. Yeah, based on what you designed for. Yeah, that's it. Our polite there was wasn't up to this 125. Yeah, but first design I checked, I used manually, so I used this, I checked it passed, so I just moved on from there. So like this one, the top and bottom curves were this, but it's a double angle. Yeah, so you need to now edit this to fit. You're not going to edit, you're going to detail this, looking at this. Some of these things you can just copy them, like this support, you can easily copy them and put here depending on the shape of your truss.